Welcome to the Wire Reinforcement Institute's Tech Check, titled Support of Welded Wire Reinforcement. Tech checks are intended to provide attendees with information needed for successful welded wire reinforcement implementation. Please note that this tech check contains WRI viewpoints and opinions. We will organize the content of this tech check into 4 buckets. First, we'll discuss the core concept of reinforcement support itself, and then provide the attendee with information on standards and documents that are relevant to defining the requirements of that support. We will then spotlight the actual ground rules for reinforcement support that can be found in the industry standards and documents, at which point we will present the various organizational viewpoints and suggestions of the Wire Reinforcement Institute. The core concept of reinforcement support is fairly intuitive. First, the design professional specifies the location at which reinforcement is to be located within a concrete cross-section. The specifier is also responsible for defining a tolerance that represents an allowable deviation of the reinforcement's placement that still maintains the fidelity of the design intent. From there, the installing contractor utilizes available means and methods to install the reinforcement within the specified tolerance. As part of their chosen strategy, reinforcement is supported by devices of appropriate strength, size, and arrangement. A few examples of reinforcement support types are illustrated here, taken directly from CRSI's RB 4.1 standard. The contractor's selection of appropriate support strategy is a function of numerous project-specific considerations that can include the stiffness of the substrate upon which the support rests, to the weight and flexibility of the supported reinforcement itself, to the type and duration of construction loading applied to the reinforcement during installation and the subsequent concreting operation. A real quick refresher on welded wire reinforcement information. A W prefix indicates a smooth surface wire. D prefix indicates a deformed surface, much like rebar. The numerical component of the nomenclature is in terms of 1/100th of a square inch of cross-sectional area, so a WL11.5 is a smooth wire with 0.115 square inches of area. A D14.7 is a deformed wire with a cross-sectional area of 0.147. Wire sizes are commonly produced up to a W31 or a D31, which is equivalent to the size of a number 5 rebar. A welded wire reinforcement sheet then would be described as follows. If the style is 6 by 12 with D20.5 by 11.2, this indicates a D20.5 wire spaced at 6 inches on center in the long direction of the mat, with a W11.2 wire spaced at 12 inches on center in the short direction of the mat. Relevant standards and documents available to inform reinforcement support strategies are shown here. ACI 301 and 117 are specifications for concrete construction and tolerances for concrete construction and materials, respectively. And CRSI RB 4.1 is a standard for supports of reinforcement used in concrete. Note that in ACI 117, a tolerance is defined as the permitted deviation from a specified dimension, location, or quantity. The WRI also has several documents related to supportive reinforcement, including its Tech Fact 702 that outlines welded wire reinforcement support suggestions, the WRI Manual of Standard Practice wherein the 702 guidance is reiterated, and various other technical blogs on the topic of welded wire reinforcement support. All WRI documents are available for free download from the WRI website. As we move into the procedural ground rules of reinforcement support, ACI 301 is a good place to start. In the mandatory requirements checklist located in the back of ACI 301, notes to the specifier are provided. Section 3.3.2.5a of the checklist states to specify location and tolerance for placement of welded wire reinforcement. Forward F2 states 301 cannot and does not address responsibilities for any project participant other than the contractor. And forward F4 states The mandatory requirements checklist indicates work requirements regarding specific qualities, procedures, materials, and performance criteria that are not defined in ACI 301. The specifier must include these requirements in the project specifications. Clearly then, ACI 301 is requiring that the specifier identify both reinforcement location and tolerance for welded wire reinforcement. This will be a prevailing theme throughout this presentation. There is additional noteworthy content in ACI 301 that is specific to small diameter welded wire reinforcement, which is generally considered to be sizes smaller than W4.0 and D4.0. For slabs on ground and slabs on composite deck, ACI 301 requires supports at 12 inches on center maximum. The same support requirement also applies for every other application in which this small diameter welded wire reinforcement material is used, but with the caveat that tolerances be per ACI 117. We will explore some of the nuances of this prescriptive support spacing in later slides. If we move into ACI 117, similar guidance to that found in ACI 301 on responsibility for welded wire reinforcement placement and tolerance is provided, and we again see that it is the responsibility of the specifier. There is also language in the form of the checklist forward indicating that ACI 117 itself addresses responsibilities of the contractor, and there is also some reiteration that the specifier is ultimately where the buck stops as it relates to information defining location and tolerance of reinforcement. A noteworthy excerpt in ACI 117's introduction commentary states that tolerances are the means by which the designer conveys to the contractor the performance expectations upon which the design is based or that the project requires. It goes on to indicate that necessity rather than desirability should be the basis for selecting tolerances. These are well-framed statements that outline what a tolerance is on a particular project or for a particular application, and why tolerances are necessary. Yet another noteworthy excerpt from ACI 117 is regarding its own applicability in the designation of tolerances. One needs to look no further than Section 1 to see that ACI 117 provides standard tolerances for concrete construction, but it also states that those tolerances govern unless the specifier dictates superseding tolerance information. Lastly, the ACI 117 commentary found in Section 2 actually defers all tolerances for welded wire reinforcement to the specifier. This language indicates that the standard tolerances found in ACI 117 are not intended for welded wire reinforcement, a deferral that we will revisit in later slides. Last but not least, in ACI 117 is a lengthy commentary that again puts the ultimate responsibility for tolerances on the specifier, noting that the default tolerances provided by ACI 117 can be overridden. ACI 117 acknowledges that tolerance values affect downstream construction costs and that pre-construction communication is critical to sorting through matters related to reinforcement tolerance that impact both the designer and the builder. This is all fairly common sense content, but it is good language for project stakeholders to review and be aware of. The key takeaways from ACI 301 and ACI 117 are as follows. First, specification of a reinforcement's design location and its corresponding placement tolerance is the explicit responsibility of the specifier. This is not the responsibility of ACI, nor the contractor. Second, standard placement tolerances, in other words, ACI's published default values, do exist for rebar via ACI 117, but are ultimately still the responsibility of the specifier to invoke. ACI 117 default tolerances for rebar can be overridden by alternative tolerances defined by the specifier at their discretion. Third, standard placement tolerances do not exist for welded wire reinforcement. Welded wire reinforcement tolerances are by the specifier. And last, Despite the absence of standard placement tolerances for welded wire reinforcement, ACI 301 still defines a maximum support spacing for certain wire sizes. We now move into organizational opinions and viewpoints of the WRI. First, the specifier's responsibility for defining a tolerance is obviously critical. This is where everything starts. Second, as ACI 117 itself states, necessity rather than desirability should be the basis for selecting tolerances. Clearly then, tolerance on reinforcement location is a direct function of the criticality of the specifier's design. Third, interestingly enough, the ACI 117 published standard tolerances for location of rebar make no reference to the actual size of the rebar itself. As such, tolerance is not a function of a particular reinforcement size. Fourth, the determination of support strategy is the responsibility of the contractor and is a direct function of their own construction means and methods, with due consideration for their own capabilities and resources and the installation time and costs related thereto. And fifth, for a particular combination of reinforcement size, construction loading, subsurface composition, and specified tolerance, there does exist a support strategy that will result in placement conforming to that tolerance. Support strategies should be application and project specific, and some support strategies may be more laborious and challenging than others, depending on the tolerance stringency that is compatible with a particular design location. A couple specific WRI thoughts on ACI 301's prescriptive 12-inch support spacing for small diameter welded wire reinforcement are shown here. The provision is mandated independent of a specified tolerance on the welded wire reinforcement location, presumably to reflect a broad sweeping concern related to the permanent deformability of light gauge welded wire reinforcement when it is subjected to significant construction traffic and equipment. But as far as ACI mandatory language is concerned, there seems to be a procedural breakdown with this provision. And here's why. In the absence of a specifier's definition of a particular application's reinforcement location and its accompanying tolerance, as well as an absence of insight into how a particular placing contractor decides to deploy its means and methods, how does ACI know ahead of time what the maximum support spacing must be? How can there be a mandated output without project or application-specific input and decision-making on the part of both the specifier and the contractor? In short, it is the placing contractor's responsibility, not really ACI's, to deploy support strategies compatible with a particular reinforcement application's specified tolerance. And as ACI 117 and ACI 301 clearly state, it is the specifier's responsibility, not ACI's, to specify the welded wire reinforcement location and tolerance that ultimately shape a placing contractor's strategic decisions. So much like ACI 117's published standard tolerances, serving as a movable guidepost for specifiers, so too might ACI 301's 12-inch support spacing be treated by contractors. The WRI provides support spacing suggestions to consider for various wire spacing ranges of welded wire reinforcement sizes. These suggestions can be found in Tech Fact 702 as well as its Manual of Standard Practice. It is important to understand that these suggestions are simply a starting point and do not constitute a formal specification. The basic tenets still apply. First, the specifier must define both the reinforcement's design location as well as the permissible tolerance on that location. Second, the contractor derives and implements a support strategy that achieves conformance within the specified tolerance. The table shown here is a general swipe at ranges beyond which the contractor can dial in on their project-specific support needs. Small diameter welded wire reinforcement, also known as light gauge mesh, is characterized by sheets with wire sizes that are smaller than a W4 or D4, and it tends to occupy its own unique category, so it's appropriate to focus a spotlight on this material for a couple of slides. Small diameter welded wire reinforcement is used in a wide variety of applications, some of which are listed here. Nominal slabs on ground, including sidewalks and some light-duty paving, are generally non-structural in nature. As such, the reinforcement requirements are typically quite modest. Equipment support pads can either be ground supported or formed and poured on top of a structural slab system below. These are characterized by fairly isolated footprints and do not typically experience significant internal forces given the presence of competent sub-base support below. Topping slabs and overlays are thin concrete layers and often require a correspondingly small diameter reinforcement to achieve the intended concrete coverage and steel proportioning. Similarly, some concrete repair types benefit from smaller reinforcement sizes that can be field shaped. The precast concrete industry utilizes light gauge welded wire reinforcement fairly extensively in modular type structural elements like double T's, sound wall panels, and precast stadium risers. And last but not least on this particular list, shotcrete applications can benefit from the ability to easily field shape the small diameter reinforcement to suit the intended geometric profile. If we focus on light gauge welded wire reinforcement in nominal slabs on ground, there are well-documented challenges that must be considered given that the most common construction methods involve the presence of both worker and equipment traffic. Because the wire sizes are so small, they are more sensitive to displacement from their intended positioning. Additionally, and depending on the construction loading incurred and the interval of support, the wires themselves can actually be permanently deformed. The specifier, as we've noted previously, is responsible for defining the design location of the reinforcement as well as the accompanying tolerance that would still allow for the design intent to be achieved. The specifier should also be constructability minded and have an awareness of potential downstream construction challenges that could arise as a function of a chosen design solution, including site activities that could impact material deformability that leads to yielding. On the job site, the contractor is tasked with building the specified arrangement within the tolerance specified. For a slab on ground, depending on the design criticality, the specifier's tolerance may be perceived to be stringent or comparatively lenient, and this in turn can affect whether the light gauge welded wire reinforcement solution requires supports at 8 inches on center or 12 inches on center or even 36 inches on center. The point remains that for a given set of design and tolerance inputs, a construction solution does exist, though it may very well diverge from a contractor's preferred mode of economical operation. If there is contractor hesitance or reluctance related to a particular design solution as presented by the specifier in the contract documents, it is important these concerns be voiced and reconciled sooner than later. For a typical design bid build delivery method, there are generally two main options for a contractor. They can either no bid on specified work that they aren't confident that they can execute, or they can inquire about an alternative reinforcement pattern that might still achieve the original design intent, but by way of an easier support strategy. In contrast, if the construction is to be executed as part of a design build model, specifier contractor collaboration should be baked in from the start of the project, with issues related to execution of a particular design intent largely resolved before they actually become issues. Regardless of the project delivery mechanism, there is no substitute for early communication. It is an obligation needed to be upheld by all stakeholders. Light gauge welded wire reinforcement is a viable reinforcement solution for slabs on ground, but consideration for the steps needed to execute this solution is the responsibility of both the designer and the contractor. Some overarching thoughts for specifiers and contractors related to support of welded wire reinforcement are offered by the WRI here. First, for the specifier, consider the criticality of the design. In other words, structural versus non-structural and serviceability considerations. These directly impact reinforcement position. This will inform the appropriate specified tolerance and how stringent or lenient it can be. Additionally, be aware of the impact that a selected tolerance can have on the complexity of construction. Be constructability minded. In one instance, this might take the form of avoiding a disproportionately tight specified tolerance for an application in which the steel isn't explicitly relied upon by the slab for strength, such as in flexure or shear applications. This would be a good example of not asking more of the reinforcement's position than what the design actually needs. And in another instance, if the design criticality is such that the tolerance on reinforcement location is stringent, just know that smaller diameter reinforcement material will almost certainly require a more robust system of support in the field, and that there might be other welded wire reinforcement sizes and patterns that strike a superior balance between design intent and constructability. And then for the contractor, you are responsible for conforming construction based on specified reinforcement location and tolerance. If there is a concern that you lack the means and methods to cost effectively achieve it, considering inquiring about an alternative reinforcement solution, or perhaps even withdraw involvement if the situation can't be shown to be favorable for your operation. Not all contractor capabilities and business strategies are the same, and decisions need to be made accordingly from one entity to the next. Also keep in mind that no reinforcement has infinite stiffness, and depending on your chosen means and methods, some material is more susceptible to permanent deformation than others. Derive a support strategy accordingly. Unless otherwise defined by the specifier, the specified tolerance applies at all locations, including at the points of support and between supports. Regarding the flexibility of welded wire reinforcement, the bottom line is that it is no different than any other steel reinforcement. One wouldn't typically support a number 3 rebar with chairs spaced at 12 feet on center, just like one wouldn't think of supporting a W2.1 welded wire mat with bolsters at 6 feet on center. Support strategy must be project and application specific, and whether it is obvious or not, all steel, both rebar and welded wire reinforcement, has a certain flexibility that must be considered when deriving the support strategy. This is not unique to welded wire reinforcement. Regarding the strength of the supports themselves, CRSI does a fantastic job of defining expectations and requirements in its RB 4.1 standard. An excerpt is shown here that references this type of information. The point here is that the integrity and reliability of the supports themselves could very well govern over the attributes of the supported reinforcement. There is no boilerplate solution, and placing contractors need to be aware of the need for bespoke support solutions to ensure that the combined system, both reinforcement and the reinforcement supports, act concurrently in a way that achieves conforming results. Regarding ACI 117 and its place in the welded wire reinforcement specification process, it is the WRI's view that a specifier's utilization of ACI 117 as a starting point for selection of welded wire reinforcement tolerances is entirely appropriate, especially considering that default tolerances therein are a function of concrete member geometries or types that are independent of the actual size, i.e. diameter and spacing, of the steel reinforcement. The standard tolerances shown here from ACI 117 are all member size or type specific, and would apply whether a number 3 rebar is being used or a number 11 rebar is being used. Logically then, a reasonable question to ask is, why would the default tolerances change if one was using a D5.0 or a D14.5 or a D20.2 welded wire size? After all, the composition of welded wire reinforcement material has the same modulus of elasticity as rebar given they are both steel, and the presence of welded intersections on a welded wire reinforcement mat would typically only serve to help stiffen the overall reinforcement assembly, not make it more susceptible to displacement. The takeaway here is that ACI 117 shouldn't be considered off limits to those who are seeking a jumping off point for default tolerances related to welded wire reinforcement. On the topic of ACI 301's maximum support spacing for small diameter welded wire reinforcement, a contractor should closely consider the ramifications of strictly adhering to this requirement sight unseen, as the prescription does not guarantee conformance with a particular project's specified tolerance, nor does it allow for alternative support patterns or methods that could achieve conforming results. there should be a cautionary flag planted in this prescription, considering that it isn't based on a particular specified reinforcement location and tolerance, nor does it afford competing contractors the full latitude to derive construction solutions themselves. In summary, for support of welded wire reinforcement, the specifier must define design location and tolerance. The contractor must determine the necessary means and methods to achieve conforming construction. Specifier and contractor collaboration is extremely important. The project's success depends on it. ACI provides standard tolerances for rebar, but not for welded wire reinforcement. Regardless, in all cases, both rebar and welded wire reinforcement, tolerances are ultimately the specifier's responsibility. Remember that ACI published standard tolerances are not reinforcement size specific. And lastly, ACI 301 prescriptive spacing for small diameter welded wire reinforcement should be carefully considered, as it is not a catch-all solution. Thank you for your time. For more information, please visit the WRI website.